In this last video of the chapter, we will be using factoring in order to solve equations. The first thing though we need to review is the zero product property. And what the zero product property says is if I have terms that are multiplied and the result is 0, then at least one of these has to be 0. Meaning A would have to be 0 because no matter what B would be, 0 times B would equal 0, or B would have to be 0. And A could be any number, because as long as you have one of the variables equal 0, the end result will be 0. And again, we're going to use that in order to solve equations by factoring. If you take a look at this, we have an equation set equal to 0, and between the two parentheses is implied multiplication, meaning that this parenthesis could be 0, and it doesn't matter what this is because the end result would result in 0, or vice versa. So what you do is you use the zero product property in that sense that I'm going to set 8x plus 3 to 0, and I'll set 2x plus 1 to 0. Because if either this or that is 0, it would make it true. So 8x equals negative 3, x equals negative 3/8, and then I'll solve for the other one, x equals negative 1/2. So I can plug in negative 1/2, and obviously over here it would be negative 4 plus 3, which would be negative 1. But when I plug it in over here, it would be negative 1 plus 1, which would result in 0, automatically making the end result 0. The same would be true with 3/8. If I plug it in over here, it results in 0, while over here it doesn't really matter. Unfortunately, not all of them are going to be factored for us. So what you want to do in those cases is, first of all, make sure that it is set equal to 0. 3x squared minus x minus 4 equals 0. From there, you'll want to factor. Now again, you can either use guess and test, or you can use factoring by grouping. I'm going to do factoring by grouping just to give you another example of that. 3 times 4 is negative 12. The 3 and the negative 4 give you that negative 1. So I'm going to use that to split the middle. I'm going to take out an x over here. I'll take out a 1 here. And I'll get x times the quantity 3x minus 4 plus 1 times 3x minus 4. Regroup it and get x plus 1 times the quantity 3x minus 4 equals 0. And again, what I'm going to do is I'm going to set each of these equal to 0 and solve. Over here, x equals negative 1. For the other binomial, x equals 4/3. Again, either one would be a solution, because if I go and I plug it back into the original statement up here, it would work. It would equal 0. Example number 3 is already set to 0, but let's look at what kind of factoring problem it is. Again, number 1 rule of factoring is GCF. You'll notice that both of them are divisible by 5 and x. So I'll take out a 5x. And you'll also notice that that's factorable again. That's actually a dot. So x minus 4, x plus 4. And in this case, there are actually 3 parts to this, because it's all multiplication in here, and each one could be set equal to 0. So I set each part equal to 0, and I solve. X could equal 0, x could equal 4, or x could equal negative 4. Number 4 is a little bit more complicated of a problem. You'll notice that it has two binomials over here. which would make it nice if we could just set them equal to 0. But you'll notice on the right side, it's not. So what we have to do is we have to FOIL and actually combine like terms. So when I FOIL, I get a squared plus 4a minus 12 equals, let's combine that, a minus 8. And if I bring it all together, I get a squared plus 3a minus 4 equals 0. And then from here, I'm going to want to factor. Again, make sure you don't try to set these equal to 0 because the equation itself isn't. So I'm going to factor here a plus 4, a minus 1, and I get a equals negative 4, and a equals positive 1. And finally, our last example. We haven't seen too many factoring problems like this because you'll notice that they have 4 terms. But this should seem a little bit familiar because when we factor to grouping, we actually take the trinomial and we make it into 4 terms. So in this case, we just start kind of in the middle of the process. I split it, take out the GCF, p squared times 2p plus 1, negative 49 times 2p plus 1. Regroup it. You'll notice in this one that the p squared minus 49 is actually still factorable. So I'm going to do p minus 7 and p plus 7. And then what I'll do is I'll set each one of those to 0. So p could equal 7, negative 7, or negative 1/2.